Good morning, everyone. Today, my topic is applications of automata in gaming theory. Abstract. In gaming theory, presenting players with strategies directly affects the performance of the players. Utilizing the power of automata in one way for presenting players with strategies. In chapter, the authors studied different types of automata and their application in gaming theory. They found that finite automata, adaptive automata, and similar automata are widely adopted in gaming theory. The applications of finite automata are found to be limited and present simple strategies. In contrast, adaptive automata and cellular automata are intensively applied in complex environments, where the number of interactive players is high and therefore complex strategies are needed. Uh, Introduction. Obviously, the game theory can be presented in a wide range of applications. When car driver puts a plane to drive in heavy traffic, they are actually playing a driving game. An election choosing platform is a political game. The owner of the factory deciding the price of the product is an economic game. These are some of the examples. About the gaming theory. Gaming theory is a mathematical analysis of the interaction between individuals strategically. The interaction between the agents who may be individual groups, firms are interdependent. Interdependent interactions are controlled by the available strategies and their corresponding payoffs of the participants. Generally, the game consists of the following players, where one side of the game tries to maximize the gain, while the other side tries to minimize the opponent's score. However, these players can be human, computer applications, or any other things. Environment. This includes broad positions and the possible moves for the players. Terminal test. The terminal test specifies the game is over and the terminal state is reached. Utility function. The utility function is a numeric value for the terminal states. The basic history about the gaming theory. Uh, the first formal study of the games was done by Cornett in 1838. The mathematician Emily Purcell suggested a formal theory of games in 1922. The concept has been basic point of analysis since then. Game theory received a special attention in 1994 with awarding of Nobel Prize in Economics to Nash. Because of this, gaming theory has been broadly used in economics, biology, politics, law, and also in computer science. Example on the use of game theory in our computer science, including interface design, network routing, uh, load sharing, and allocate resources in distributed systems and information and service transactions on internet. Automata types. An automata is a self-operating machine. The output of the automata is combination between consequences of the current point and the history of the machine's previous input. An automata is designed to automatically follow a predetermined sequence of operations or respond to encoded instructions. There are many types of well-known automata, such as finite automata, Turing machines, push-down automata, adaptive automata, as well as other variations such as random access machines, random access machines, and array automata. Learning about automata theory. Learning is strongly associated with the past experience, where the experience are meant to be permanently change the entity behavior. Learning system is categorized by its ability to improve its behavior with the time. In some senses, tending towards an ultimate goal. Numerous approaches have been proposed for developing learning systems. One of the approaches which gained considerable attention is based on automata. The approach tends to present a given problem as one of the findings, the optimal state among the set of possible states. This approach is referred to by learning automation. The learning automation operates in a random environment. The actions are chosen based on inputs received from the environment to find the optimal. This is one of the example where maximum outputs are given to S3 and S5 by S1, S2, and S4. Applications of automata in gaming theory. Automata theory has presented various types of automata with different characterizations. In this section, we'll go through applications which have successfully utilized the concept of automata in gaming theory. Applications of automata. Back in 1985, Nyman tried to model the fact that players can do only bounded computation by modeling the prisoner dilemma players as finite automata. 1 year later, Rubinstein tried to show that costly computation may affect an agent's utility. Rubinstein assumed that the players choose a finite automata to play the game instead of choosing a strategy directly. It was clearly stated that the player's utility depends upon it was clearly stated that the player's utility depend upon automation move and complexity of the automata structures. In 2000, Lewis formalized the idea of finite automata and pressure dilemma instead of modeling players as polynomially bounded Turing machine. The work presented showed the benefits of the finite learning automata, which help the agents to find the action that minimizes the expected number of penalties received or maximizes the expected number of payoffs received. On the other hand, there is a difference between environment for representation. The players in trees or graphics using ES techniques based on many factors that in turn affect back the outcome of the evolution of the strategies. Some of these factors include the number of players, technique of the evolutionary competition, type of automata, and neighborhood structures. Finite state automata. Finite state automata is one of the well-studied automation models in theoretical computations. Finite automata are composed of fixed finite memory, which takes the decisions using the finite memory, a finite non-empty alphabet, a transition function, an initial state, and set of final states. Transition map ordered a pair of specific current states and the current input symbol into a new state. Finite automata are classified into deterministic finite automata and non-deterministic finite automata. The DFA is also permitted to be in only one state in any one time. On contrast, NFA can be in two or more states at any given time. Technically, adding restrictions to DFA is sufficient to transform it into a NFA. In given example, R is taken as input at A to go to B, and alpha is taken at input as input at A to go to B. DFA can be viewed in two methods: graph based and table based. Graph based method is considered efficient for visually represent the player's behavior, with table based transition listing method is efficient for simulation. Morris machine. The output depends only on one state. Morris machine is efficient in simplifying a given behavior. Miller's machine, the output depends on specific input and a state. Miller's machine is efficient in reducing the number of states. Finite automata are widely used in gaming theory, for instance, in literature n-player prison dilemma. The finite automata can be used to represent player strategies. The automata state represent the player's action and input the strategy's profile observed from the other players. Therefore, the n represents the number of players in the game. Then the set I is defined as from 0 to n minus 1. The set of states S can be divided into two states, C and D, such that the players corporate or defect it ST include C or ST include D, respectively. Figure shows an example of the strategies for the NPPD with three participants. In the given example, the input 1, 2 is self-looped to C1, and the input 0 is taken to D1, and 0, 1 is self-looped to D1, and the input 2 is taken from D1 to C1, and the input 1 is taken to C2 from C1, and the input 0 is taken to D2 from C2, and input 1, 2 is taken from D2 to C2. First, the player selects C as initial state. If in round one none of the two players played C, the total number of corporator will be 0. Transition 0 will change the current state from C1 to D1. In the following round, the agent will play D. Since the current state is D1, assume that one player is corporated. Therefore, the total number of corporator will be 0. The transition 1 change the state from D1 to D1 itself. The next round, players will play D1 again. Conclusion. Presenting player strategies in gaming theory is one of the factors which affects the player's performance significantly. In this work, we have analyzed the characteristics and the underlying structure of existing type of automata. Uh, We have explored the applications of automata in gaming theory. However, this study revealed that only few types of automata have been utilized in gaming theory. We found that the finite automata have been widely used to represent simple agents' behavior. On the other hand, adaptive automata and cellular automata are mainly used to represent complex agents' behavior. The complexity level of the both adaptive automata and cellular automata is determined by the number of states in automata. The more states you have, the higher is the capability for the automata to handle the complex strategies. Thank you.